Hello, this is the Tepid Coder. In this video, I want to continue where I left off with my linked list example. Before I do convert this into a C++ version though, I want to finish off one thing I forgot to do in the last video, and that is iterate through the list in reverse, just to show how that would work. And there's also one thing I think I can do better. Before I was adding a node and I was returning true or false, a better thing I could do is actually make it return a pointer to the node that it just added. So in this case, whatever this variable is right here, it's a pointer to a pointer, right? So I'm basically referencing some variable that points to a node somewhere in memory. And I'm reassigning that to equal the address of a new node somewhere in memory. And then I'm returning, it was going to be this as a bool, so if this is non-zero, then it would return true. In this case, it's going to assign it to the position, it's going to redirect this variable that was passed to this address in memory, and then it's going to test that address that it redirected to see if it's zero. And, well, I guess it doesn't need to test it really, it just, whatever that equals is going to be what's returned. So, it should work just the same, basically. It gets pointed to that new address, and then that same address is being used again as a return value. And over here, instead of returning true, I could just do return LP next from the node, or if I really wanted, I could be even lazier and say return. So just like before, the next node is getting assigned to some new value in memory, and that same thing that we just assigned is used for the return value. So I'm just returning that new node. Okay, and that lets me do something pretty cool. Now I can actually say I have a new thing called, let's say, end, right? One to 0 by default. Now note that I put a star here. If you're doing pointers, so I have like char pointer p, right? And I do comma s, let's say. This would define char p, and it would also define char s, like this. It's not a pointer. So if you have a pointer, you need actually to have a star in front of it, right? I could put 2 or 3 of them, doesn't really matter. But you actually have to put them each time. So I have a node pointer called list, and I have a node pointer called end. Alright, what I could do now is I could say end equals this. Say if not end, and we failed to add the node, right? Because it points to a bad address. We're in C, so I'm doing fprintf here. Okay, standard error. I'm going to say error couldn't add the first node of the linked list. Right. Return 0. Okay. I'm going to steal that for a second. And over here I'm just going to say if not, end equals this. That does the same thing. A little bit more of a lazy way to do it. Okay. Do something here. If not, end equals this. Okay. I don't know why I had to type that out just now, but I felt compelled to do it. Okay, so we couldn't add the second node to the list. Couldn't add the final node to the list. Cool. So now, one thing you might be noticing here too is that since we're storing the in node, we don't really need to add the node in the same way where we'd start at the beginning of the list if list is null that you're passing. I guess we have this variable here, list. Currently, like when you start out, it points to 0. So right here, the first time we pass it, it's going to say, hey, does this point to 0? If it does, let's just redirect it somewhere else and then return right away. Otherwise, it checks to see if the next is null. And until the next is null, it keeps iterating through the list until it finds a null node. We don't need to do that, though, if we have the end of the list already. What we could do each time is we could just always say end equals something like new node, and just say, like, geez, come on, the tepid coder, and then 10. So I could do that, and I could, after that, say it equals something like end equals new node. You know, what was the second one I did? Some better coder. That was 15. But to think about that for a second, so it'd be list equals this in that case, and over here it would be list liar. List LP next equals this. That's also the end of the list now. And when I do new node, I think I have to pass the previous, don't I? What did I put in there? Yeah, previous. Cool, okay. So in this case, the previous is just 0. In this case, the previous would be the list. Through the list. And over here, if I did that, it would be equals list LP next. Actually, I could just do What is it? Think about that for a second. Yeah, I could always just do end LP next. There we go, that's looking better. In this case, I would always just put end here, whatever the current end is, and then non-coder, I think I called it, 105, is that right? Surprised to remember that from yesterday. Anyway, maybe I'll try that out real quick. I'm not doing any error checking right now, which is stupid, but just to see if this works real quick. And I'm deleting something down here. Which one is that? I'm deleting the last node, it looks like. So, okay. Oh, this needed to be commented out as well. That's what was confusing me there. Alright, let's just try that real quick. G++, test.c, out is test. Test. Okay, so you have the tepicoder and some better coder. Those two worked. And then, let's not delete the last one real quick. Just show them all in there. Clear. Okay, all three are in there. Let's get rid of the middle one this time. Okay, tepicoder, non-coder. Let's get rid of the first one this time, the root list. Yep. So those all look to be working. So now what I want to do here, I think, yeah. I'm going to do it the way I had it now. Even though this is a better way to do it, because I'm always able to just push to the end of the list. I'm going to do it the old way for a second. And I want to just iterate the list backwards the old way. So I'm going to do for node equals, I'm going to say end node. So while this points to something valid, node equals node LP prev. So it's always going to go to the previous node now. And better coder, tepicoder, went backwards. It's not any harder to iterate to the list in reverse. It works the same in both directions. You just go to the previous or you go to the next one each time. So that's pretty cool. And we're able to optimize the list so we can add to the beginning or we can add to the end. The other thing too I should have shown is how I can add a node by pushing the list forward. Because it's entirely possible that what I can do is if I have like, I don't know, 1, 2, 3, and I add a new node, I could add like 4 here, right? And just set the root of the list to point to this. So it could be something like, I'll do this. I'll say push front. I'll just call it that. Kind of like the standard template library we call it. Okay, so I'll do bool for now because I'm not exactly sure how I'm going to handle it yet. I don't want to put no. What am I do here? Think about that for a second. Okay, so node of list, and then just the parameters really. So const char star. Was it name and then age or something? Age. Yeah, that would say node equals. I don't need to type this. I don't need to typecast this in C, but I just do in case I want to convert it to C++ later or something. Doesn't hurt anything. Okay, so I'm allocating the size of node. So I'm allocating enough memory to hold one node. And after that, let's actually say node member lpsc name equals strdup. So I'm duplicating the string, allocating a new block of memory and copying the string into it. And the string I'm copying comes from this argument here. Okay. And then node UI8 age equals UI8 age, just like it was passed to us. Now what I can do is I can say list needs to point to this. Before I do that, I'm going to say node LP next equals list. So the first node of the list. Okay. And then list. Yeah, list. Okay, previous equals the node we just allocated. So basically we've just pushed it forward because whatever was the start of the list is now pointing backwards towards this node we just created, and this node we just created is now pointing forwards towards that old first part of the list. Now the list itself needs to point to this node instead. There we go. So now what I can say here is if not node, so if we failed to allocate it, return false. Otherwise we're going to return true over here. And in this case, it doesn't really make sense to return the pointer to the new node. We don't really need to. I mean, I guess it doesn't not make sense. It's just, it's always going to be the start of the list. This is going to point to it on success, so I don't know. Do I care about doing that or not? The other thing I should test too is if not list, then we have an issue, right? Printf. This is like your fatal error because the coder passed us a bad reference to a variable. The reference to the root of the list that was passed to push front was invalid. Bad. What am I doing? Yeah, we're going to do exit 0. I'll exit the OS, because that's a problem the programmer made. It's a logic error. It's like if they called push front with 0 right here, or null pointer, or some variation. They're supposed to do and some variable, right? List, right? Say do something like node list equals 0, right? That's what they should be passing us, plus some arguments. Okay. And in the case where this currently points to nothing, I can't just dereference it like that. So I need to account for this. So if list, if it points to something, then I need to make whatever it points to have its previous pointer point to our node. Alright? And this is fine. It can point to wherever that points. Because if that points to 0, we're just pointing to 0, which is fine. That's accurate. And we make it list root pointer point to our node now. That should be fine. So let's try that, push front. So each time instead of adding a node like this, I'm actually going to push front, and the list is going to be generated in reverse, which will be kind of interesting. So let's give that a try real quick. I guess that kind of works. That did save me some time. Yeah, I'll just copy like this. Trying to think how to do this quickly. I've been thinking about actually pre-typing these videos out and just kind of like going over a prompt of something already written, maybe. I don't think that'd be as fun to watch, though. Like, when I watch people program, I tend to prefer it if they're thinking on the spot. And I feel like maybe I explain things better if I'm thinking on the spot, but at the same time, I also might just get kind of too distracted with what I'm doing and not explain things very well, so. What are you guys' thoughts on that? Should I maybe plan these out better and have them pre-typed out and then just go through the code? I don't know. Anyway, so I'm going to push to the front each time. So this list should get pushed forward over and over again. And by the end of the list, this should be the first, second, third. And I'm printing out the list in both directions, forward and backwards. So I'm expecting to see non-coder, some better coder, the tepid coder, and then the tepid coder, some better coder, non-coder. Let's see what happens. So non-coder, some better coder, the tepid coder. So obviously something went wrong there. Oh, right, because end isn't actually ever pointing to anything. Here, end equals list. Because the first thing that I'm adding is going to remain the end. There we go. Yeah, so that works just fine. I can do non-coder, some better coder, tepid coder, some coder, some better coder than non-coder. Whatever. So I'm able to iterate in both directions. So I'm glad I got that all working out of the way. Obviously, the current add node version I have is basically like a pushback, except I'm not storing the end pointer. So it's doing a linear search. Linear search just means like if you're trying to find something, you have a list of like 0, 1, 2, 3, 4, 5, 6, whatever dot n minus 1. If you're trying to find like the 4, you'd start here and you'd say, okay, not that one, not that one, not that one, not that one. Okay, here it is, found it. So that can be kind of slow. There's faster ways to search lists if they're sorted. You can say like, okay, let's start in the middle of the list. Is it less than or greater than this item? If it's less than, okay, let's go then, you know, halfway back to the start. Okay, is that less than or greater than? Oh, okay, this time it's less than, we need to go the other direction. So what's halfway between there? Maybe we end up right here. Like, okay, is less than or greater than? Okay, it's less than, so we go here. So for this case, it ended up being just as fast, really. I think it was 4 steps I just did. It's like 1, 2, 3, 4, yeah. So it ended up being the same, but if you have like millions of items in the list, it ends up being like log of n, the time complexity. I think that's right. O of like log n. which means like it'll take like log of n steps in order to find what you're looking for, or worst case. Anyway, whatever. Now that I have that done, I can actually start working on a C++ version of this real quick. And this will be a little bit more wieldy. I think it'll be more fun. Anyway, if you like what you saw in this one, give it a thumbs up, and consider subscribing for more content like this. And in the next one, I will proceed to do this in a C++ way that people might find more interesting if they're more interested in the C++ side of things. Anyway, I'll catch you guys in the next one. Have a good day.